Hey guys, let's go over lesson 2.7, which is assessing a regression model. Like, is it good enough? What's our learning targets? We're going to use a residual plot to determine whether a regression model is appropriate. In this case, in this lesson, we're specifically thinking, is a linear regression model good? Learning target number 2, interpret the standard deviation of the residuals, and learning target number 3, interpret R squared. Okay, so for learning target number 1, using a residual plot to determine whether a regression model is appropriate. Now that we've learned how to calculate a least squares regression line, it is important to assess or figure out how well the line fits the data. We can do this by asking 2 questions. Is the line the right model to use, or would a curve be better? And if a line is the right model to use, how well does it make the predictions? So, how do you tell if a line is a good fit for the data? Well, we use something called a residual plots. Residual plots. Okay, so what is a residual plot? A residual plot we call that RP, can reveal patterns that were not apparent or not obvious in the original scatter plot. What's another way of saying it? A residual plot is actually a scatter plot. That plots the residuals on the vertical axis and the explanatory variable on the horizontal axis. Okay, so let's make sure we understand. This is a scatter plot. This is a scatter plot of miles driven versus the price. So if you drive a car a lot and you have a lot of miles left, then it's actually worth less. Seems pretty obvious, right? And then a residual plot is here in green. Okay, remember, as a quick review, residuals is the actual minus the predicted. Right, and this one is below and this one is above. Well, if you take those values, and if you're saying this is above and these are the prices below, here in green you have something called a residual plot, right? If it is 0, then it's actually, the actual minus predicted is 0, so it's actually right on the line, okay? And I have 2 other examples over here. Here's a scatter plot of Super Bowl number, and then the residual plot is down here. Okay? Alright. Let's go down below here. Interpreting a residual plot. A residual plot can reveal patterns that were not apparent or obvious in the original scatter plot. What do we look for? Well, a bad thing is we want to see if there's a curved pattern. So it's bad if we do see a curved pattern, because it basically is saying the relationship between an x and y is not linear. Okay, what else is bad. Changing vertical spread. Meaning predictions will be less accurate for some of the values of x, although a line may still be the best fit, but we need to be careful about those predictions. Okay, what is good? A uniform, even, random scatter. Meaning any errors in our predictions will be random and about equal for any value of x. A line is a good fit. Also, small residuals mean the line is a better indicator. Let me highlight this one. So when you have a random scatter, okay, in the residual plots, then the line is a good fit. So we want to kind of see it all scattered out. Let's make sure that we have this super clear. Let's look at the truck one above. So again, yellow is scatter plot and green is residual. Can you see any patterns here in this residual plot for data for the truck one? Okay, so it is scattered, and this means it is good. It is good. This will look good for our line. Okay, let's look up here. Let's look at Super Bowl. Okay, that's the scatter plot in yellow. But when you calculate the residuals, okay, what do you guys notice? You actually notice a pattern. So let's write that pattern. This is bad. Okay, so that's just like the big idea for page number 1. All right, let's go down to page 2 now. Making a residual plot in your calculator. So I want to note that these steps up here are specifically for a TI 8384. And I took a survey, and that was the second technology used. Number 1 was actually using kind of like what I'm using, a tablet and an app, okay? So they're kind of like 98% accurate. So making a residual plot in your calculator, we're going to enter the data into list 1 and 2. Number 2, we're going to take the equation of the least squares regression line by pressing stat calc, and then we've been using number 4 and number 8 are pretty much the same, which is linear regression. Then something that's new is we're going to make the residuals plot. So we're going to press stat plot. We're going to turn it on, make sure it's scatter plot. Okay, I figured out my tablet is, you guys know I like kind of like the dark mode, dark reader mode where it's always black in the background. Those were kind of covered in the calculator I was using, so now I can see it. So I turned it off to the theme in my tablet to be light or white, and then now you can see it. And then it says list. Usually in the list 1, we're going to put the explanatory variable, and then in the Y list, we're going to put residuals, which is second stat, and then scroll down to residuals, and then we're going to press, look at the graph, and then zoom number 9. Okay, so take a quick picture of this. And let's do this for example, this one here at the bottom. Let's go ahead and do this one right here. Okay, so let's go to, I'm going to use Graph and Calc 83. Okay. I don't have the list. What happened? Let's go back. Don't have a picture of that for some reason. Let's take a picture here. Okay. Alright, now I've got it. Let's go put this into our calculator. So from here, I'm in the home screen. If you're not, you just press second mode. Or you can press clear. And then I'm going to press stat. edit, and I'm going to go up to list 1, press clear, enter, go up to list 2, clear, enter, and then now I'm just going to type in all those numbers. So 2, 4, and press enter after each number. And then go up here to my Y list. Oh, missed a number. Five, 15, 26, 23, 11, and 3. Okay. So once I put in those numbers right there, let's go follow the directions that we just wrote. So now I'm going to go to Stat, Calc, linreg. Okay, so again, it said number 4, but on mine, on the screen, it's 5 or 9. So you can use either one. I'm using 5. Okay, and then it tells me to just put in the list numbers. So list 1, list 2. Again, there's 2 ways to put list. You can just press in second and then number 1 and number 2. Or you can go to the left key, near the left key, press second, stat, and it gives you all the list of them. See? So there's list 1, comma, I'm going to press second, stat, and then you can press enter. Okay? So this gives me, just review, A is slope, B is the y-intercept because it doesn't have an x there. R value is the correlation, and then today we're going to learn about R squared, which is the coefficient determination. Okay, how do we get a residuals plot? Well, now we're going to press stat plot, which is at the very top where it says y equals. So I'm going to press second stat plot, and then I'm going to go ahead and click this first one. Okay, and we have here scatter plots, and then let's see. Okay, so for mine, I just had to like kind of scroll through, and it says resid, and I just press done, and then we just press. Normally there's a zoom button that's like in the middle, but we don't have that on this kind of like fake TI graphing calculator. So I'm just gonna press graph and see what happens. Okay. All right, there is my kind of graph of the of my residual plot. Okay, here's the question: is it scattered? It is kind of scattered, but is there a pattern to it? And it does. It kind of looks like a parabola, upside down quadratic, right? A value is negative, facing down. So this one does have a pattern. So let's go back over there. You know, and you could just draw a quick graph if you wanted to. Not necessary, but the points kind of looked like that, right? So it looks like there's a pattern. So pattern, and this would be bad. Okay. All right, for the rest of these, go ahead and write, let's read the directions. Is it good, okay, or bad? Determine if the following residuals are good or bad. Determine if the regression line fits the data. Another way of saying it is, does the residual plot suggest a linear relationship? I'm going to press, you press pause, and I want you to finish the rest of these 11 problems here, and then I'll go over the answers. Okay, let's kind of look at this one here. You can kind of connect the dots and see that there's really no pattern here. It is scattered. So what does scattered mean? That is good. Okay, let's look at this one here. Can you guys see a pattern? I can kind of see a pattern. It looks what? The pattern has a pattern. It's curved. So we would say this is bad. We would say it's not good for a linear model. Okay, does that make sense? Let's look at some more here. Let's take a look at this one over here. Well, pattern that is what? Bad. So a linear model would not be doing well. Again, these are the residuals. This is not the scatter plot. Okay. And if you look at this one, it looks pretty similar, right? Pattern. So this is bad. Okay. So again, we kind of talked about it, but I'll just summarize it. No curved relationships. No curved relationships between these two, right? In this example and that example. Okay. What about this one here? Okay, this one has some kind of pattern. You guys see it? It kind of looks like that. So pattern, and this would be bad. How about the one below it? Again, same thing, kind of like that, right? Pattern is bad. We want it to be scattered. Okay. What are these called? These are fan shapes. I call it no fan shape. So those two examples are kind of like fan shapes. Okay. How about this one here in the bottom right? Is it scattered? Yes, scattered. This is good. That means it fits well with our linear relationship. Okay, let's look over here. Do you see how this point way over there? Okay, that's not good. So it kind of looks like there's a pattern, but this one is actually bad. And the reason why this one is bad is because residuals. Why is it bad? Residuals shouldn't, or that point, not residual, point, that point should not be extreme in the x values. Okay. How about the one above it here? This one is also bad, although it looks scattered. This one is bad because there's probably too many dots happening here. We should actually the residuals should be a relatively small size. Relatively small in size and not kind of fanned out like that. Okay? How about shoe size? Did you have time to put that in there? Okay, so if you did the shoe size, this one doesn't look like there's a pattern. I'll just kind of quickly draw what mine look like. And hopefully your graph kind of looks something like that. Okay, so I would say that one looked scattered. So this one was good or okay. Good to okay. Now, why did I say okay? Because you could kind of almost see a pattern happening. It kind of looks curved, but looks more scattered. Okay. How about the whoops, that was, let's use technology. This graph was actually this one down here, the volume. Sorry, I looked at on my answer key, the wrong one. That one was scattered to okay. My fault. Let's look at the shoe size and height. Shoe size and height. So that one on mine kind of looked like and I didn't see a pattern for that one, so I would say scattered, and I would say it is good. Okay, so another way of saying scattered, let's just make sure this is obvious. Scattered is the same thing as saying no pattern. So when the residuals have no patterns, that is good for a linear relationship. Does that make sense? All right, let's move on now to page number 3. All right, page number 3 now. We're moving on to learning target number 2. Learning target number 1, we're just talking about the residual plot. Learning target number 2 is interpret the standard deviation of the residuals. If the least squares regression line, LSRL, is an appropriate model, the question is how well does it fit the data? How good are the predictions? How good are the predictions going to be? Well, to answer this question, we have to look at learning target number 2 is the standard deviation of the residuals. That's what we're going to be focusing on next. Oops, why did I? Because it already has an R there. Of the residuals, and then learning target number 3 is called the coefficient determination. And that's R squared. Okay, let's take a look at this example here. Battery life. Can you predict the battery life of a tablet using the price? Using data from a sample of 15 tablets, the least squares regression line is y hat equals 4.67 plus 0.00068x was calculated. Using x is the price measured in dollars and y is the battery life in hours. Interpret the standard deviation of the residuals if s is equal to 1.21. So standard deviation is 1.21 based on the 15 tablets. Remember, it told us y is the battery life in hours. So you can call this the predicted battery life. Remember, the hat is a prediction. And you had 4.67 plus 0.0068. And what does x represent? Okay, x represents the price. Okay, so if you have that regression line, now they're asking us, what does the standard deviation mean? Remember, a deviation is to kind of determine how far away it is, right? So, in this problem, we can say that the, remember this one here is a prediction, but the standard deviation, we can actually figure out that the actual battery life is typically, what does it tell us? About 1.21 hours away from the predicted. And how do we get the predicted? By the least squares regression line. Does that make sense? So we're saying that is my least squares regression line, and the standard deviation is we're just saying that, you know, the actual is that it was 1.21 away from the predicted. Right? It was supposed to be that blue point, but in red there's a deviation there. Because that's the standard deviation of all the residuals. We're taking all the residuals and then finding the standard deviation. Okay? All right, let's move on to learning target number 3, and then we'll kind of put it together. The coefficient, learning target number 3 is interpret R squared. So yes, we'll go back to R. We've seen that letter before. The coefficient of determination. The coefficient of determination, R squared, is the fraction of the variation in the values of y that is accounted for by the least squares regression line of y on x. We can calculate r squared using the formula. I'm just going to quickly spit out this formula, and we don't have to use it because our calculator can figure it out for us. Okay, that is the formula. So how do you interpret r squared? Well, you're going to make the sentence frame. Blank percent of the variation in the blank, and here is the response variable, which remember is your y-axis, is accounted for by the least squares regression line relating blank. This one is going to be the explanatory variable. And blank. And I'm just going to copy and paste here. So you're actually going to use the response variable twice here in this sentence frame. Okay? Let's make sure we have that. So this is our sentence frame. Okay, a couple of quick facts about coefficient of determination. Remember, we talked about that. What is R? R is the correlation. How strong the relationship is between X and Y. So, if you have correlation, if you just square it, then you get the coefficient of determination. Okay? So in math, so we said if r squared, if the coefficient of determination is r squared equals 0.49, and let's just say you want to figure out r, well, you could just use your math skills. How do you get rid of that power of 2? What's the opposite? It's the square root. Well, what's the square root of 49? It is 7. So r here can be both positive or negative 7. And determine, if you want to know if it's positive or negative, you have to use some more information. And here's some just quick facts. Both tell you about how well the line fits on our data, right? R is the strength, and r squared tells you how well it fits on the line. But neither of these tell us about form. Remember, form, we had that abbreviation called SUD, strength, unusual direction, and shape. As r squared is going closer to 1, then your standard deviation is going closer to 0. But here you're not doing some math there. Your standard deviation has to be greater than 0, and r squared must be between 0 and 1, because if you take your r value, whether it's negative or positive, and you square, then it has to be between, it will be a positive number. And r squared has no units, because r has no units, and s, the standard deviation, has the same units as the response variable. Okay, so that's page number 3. Let's go on to page number 4 to do some examples. All right, page number 4 here. I just copied and pasted our sentence frame because now we're going to do an example for learning target number 3, which is the coefficient determination. Is Taco Bell. Find and interpret the coefficient of determination of the Taco Bell data. So I'm going to go ahead and punch this into my graphing calculator again. Press done here, press clear. Going to go to my list, so I'm going to press second, stat, and then stat, edit, go on top of my list and press clear. And then you can go ahead and put in all those numbers. So I have 12, 30, 18, 34, 20, 19, 8, 3.5, 12, 17, 9, and 5. And I'm going to go ahead and go to list 2 and type in the amount of carbs. 50, 64, 45, 88, 49, 43, 49, 16, 50, 30, 30, and 16. Okay, so again, I'm trying to figure out the coefficient determination. I want r and r squared. So I'm going to go and press stat, calc, and then we went lin reg. Okay, now I'm going to get in list 1, list 2. So again, a different way is just pressing second 1, comma, over 7, and then list 2. Enter. Okay, so here's my equation here. And A represents the slope because it's in front of x. B is the y-intercept because there is no x in there. And then r squared is the coefficient determination. But look at r. R is our correlation. If you take 0.84, just want to show you this. Guess I could do it here. 0.8429. I just rounded there. And I'm just going to square this. You get the coefficient determination. You get r squared. Does that make sense? Okay. Let's go back now and go ahead and interpret this. So what was my, think about it. What color do I not have in there? Remember, this is your r squared value. Okay. So using the calculator, r squared is how much? Point. Now we have to be careful here, guys. If r squared is equal to 0.7105, just want to make sure this is painfully obvious, okay? This is really multiplying by 100. So what's going to do here is you're going to move that decimal place 2 places. Did you guys see that? 1, 2. So this is really 71.05%. So I caught myself. You would not want to put in here 0.7105. You would have to put in 71.05%. Because remember, percent is between 0 and 100. 71.05% of the variation in, okay, now it says response variable, which is the y. So this is my x and this is my y. So y is what? The number of carbs, and the amount of carbs is accounted for by the least squares regression line relating, what was our x? Our x is the amount of fat, and the amount of carbs. Okay, let's put this all together now. Let's do an example that has all of these, okay? Example number 4, football. We previously looked at the relationship between the average number of points scored per game, x, and the number of wins, y, for the 12 college football teams in the Southeastern Conference. The equation of least squares regression line is there, and also we have the standard deviation and coefficient determination, okay? Is the linear model appropriate for this data? Okay, so you should be doing what? You're looking at the residual plot. And remember, if it is, if there is a pattern that is bad, and then if there is no pattern or scattered, that's actually good. Okay, so let's look at ours. What do we have here? Do you see a pattern? So we can say no pattern or it is scattered. So what if it means it's scattered? The residual plot Remember, you're not so definitive in stats. You're kind of you're saying these words like, it appears, it's not obvious there's a pattern left over in the residual plots. So I'm going to say the residual plot appears to have no pattern or is scattered, comma, therefore it is a good choice for a linear model. Or a linear model would be appropriate. Okay? All right, what does S stand for? S is, whoops, circled the wrong thing, is our standard deviation of the residuals. Interpret, so they're telling us now that the value of S is 1.24. What does that mean? Using the least squares regression line, where X is the points per game, 2, here's a keyword, I'm going to change colors. Nope, it didn't change colors. Predict the number of wins, Y, the number of wins. What does that mean? We're typically going to be off by what? Typically off by 1.24 wins. Okay, so you go over here and you guessed above from the actual, right? The lines are predicted and the actual is the point. You're off here, right? Some student did a Christmas video project and the amount of time it's going to take them to clean up, right? Sometimes you overestimate, sometimes you underestimate. So the standard deviation is kind of like that spread. Okay, interpret the R squared equals 0.88. So then you're just using that sentence frame. I don't know, you can do what I'm doing or rewrite it. Then I just have to erase stuff in it. All right, let's use our sentence frame here. What was our R squared? Our R squared is 0.88. So what percent is that? That's 88%. Remember, multiply that by 100 of the variation in the, what is my Y variable? It told us above, and you can look at up here, the predicted number of, the variation in the predicted wins, or just wins, is accounted for by the least squares regression line relating the wins and what was the x-axis, points per game. Okay? All right. You guys go on to page number 5 and you do it all. It would have been more difficult if I just gave you some data, but I made it a little bit easy and actually gave you some graphs and some data. So you guys do number 5 and I'll quickly go over it. All right, next page 5 says back on track. We previously looked at a relationship between the 40-yard sprint times measured in seconds and the long jump distance for a small statistics class with 12 students. The scatter plot with least squares regression line is here, and there you are. You have the predicted long distance jump, and the residual plots are shown with the graphs, and S for standard deviation and R squared coefficient determination. Okay, here is a review question. Calculate and interpret the residual Remember the formula for residual is, well, we always wanted you to go to AP statistics. So that is the actual minus the predicted. Okay, what does that mean for us? If you write down his equation, so y hat equals 4.4, geez, 414.79 minus 45.74x, okay, and 7.25. 7.25 is your sprint time measured in seconds, right? So there goes this. So now I have the, if you put, why do I do that? I gotta start again. Oh. Someone know why that does that? And I went back into the original thing. Okay, try that again. So y hat and then we said that the x is the sprint time, right? Well, sprints are measured in seconds. So I'm just going to put in my data here. And then your predicted will be a total of A3.175. Okay, so we found the predicted. Now we need to calculate the residual. So we said that was the actual minus the predicted. So his actual was 110 inches, right? So his actual is there, and then his predicted was, well, he's gonna do that in red. So let's just fill that out. So his actual was 110 minus his predicted, which was 83.175, and if you did that, you get 26.825. That is his residual. Now, just a clarification, right? So if you look at the graph, and if you type in, or 7.25 is like right here. Okay, so we were expecting, right? This is what we calculated. We calculated the predicted to be 83.75, which is like right there. Okay, but let's use a different color. His was 26.25. Well, he actually did 110, which is way up here. This is his point right there. Okay, so we're saying that is a difference of that purple difference. The residual is 26.825. So he did, based on his sprint time, he actually did a long jump way better than we had predicted. Right? He did 20 inches further. Wow, it's like almost 2 feet. Okay. 5B, is the linear model appropriate for this data? Again, you should be looking at the residuals, the residual plot, and you guys see any pattern? I see no pattern. So there is no pattern in the residual plot. Good or bad? Which is good to use a linear model. Or another way of saying it is, because there is no obvious pattern left over in the residual plot, the linear model is appropriate. Okay, what's our next one? Interpret the value of S. So S, they gave us, was 22.38. Okay? when using the least squares regression line, what is x? X is the sprint time, measured in what? Seconds. And the y, well, what do we use that for? What did we use that in the last problem? To predict y, which is his long jump distance measured in feet. How much are we going to be off by? S was what? 22.38, so we're going to be, we will typically be off by 22.38 inches, right? Just like we were with Superman guy over here, Christian. Okay, how do you interpret r squared, right? You're just using that sentence frame. Let's copy that. You have open notes, so you can just copy the sentence frame. I'm just going to copy this one from up here. No, don't want that. Okay, so what was the r squared value? The r squared value was 0.702. So that would be 70.2% of the variation in the, what is the y is the long jump distance. Long jump distance. So again, write this sentence right in your formula sheet. Is accounted for by the least squares regression line of the long jump distance. And what was the red? And relating it to the his sprint time, or the 40-yard dash time. Okay, so let's review what we've done so far. We used the residual plot to determine if the regression model is appropriate, whether it's linear. Okay, now if it wasn't linear, if we said it was bad, don't use a linear relationship, well, that's going to be next lesson where we can use quadratic or exponential. We interpreted the standard deviation of the residual plots, and we interpreted r squared coefficient determination. All right, see you guys.